Hello, everyone. Thanks a lot for the invitation from Architecture School of University of Waterloo. It's a great honor for me to come into this university, this country, the first time. It's a long flight, 12 hours, and also the time difference is 12 hours, so a little bit jet lag. But still, I'm quite interested in talking about my topic, introduce what we're doing to all the students and professors here. So this is actually the topic would be the collaborative laboratory, which located in my office. In the past 7 years, I have been setting up a particular research platform, Digital Future Shanghai, which is a workshop, conference, and exhibition-based event. Every year, we invited 6 to 12 teams tutored by the professors and experts from all over the world, including Phillip and Tom Mann, Philip Brock, Archimangus. These important figures in the world, they give keynotes and teaching workshops in Shanghai for 2 to 3 weeks, and focusing on the certain research topic on computational design and data fabrication. For example, the last year, the topic is visualization versus materialization. We have 14 tutors from 7 countries and 169 students from 55 universities. In 2011, Mario Capel, in his book, elaborated the shift of contemporary architecture authorship of building could be derived from the design of its final result. The development from the remark, Anthony Picon introduced the concept of design ownership and reviews the further transformation and the emergence of digital technology. According to Anthony Picon, the ownership of architecture design would be not just limited in the direct design relationship anymore, but opens to the copyright of the design tools, such as the software, plugin, and so on. And based on this kind of two sorts of notion, the contemporary architecture development, we are trying to set up some new stuff, new style, new different teaching and practice ways. So it's certain kind of critical thinking to the tradition definition of architecture. And we name it from certain kind of practice to praxis, a design application of the knowledge. So this is my office. Actually, in the last 10 years, the ivy growing, and the progressively we renovate every year in the office. And in the courtyard, we make certain kind of pavilion built every year. And exhibition space, we have also the studio space, tea house, we have a robotic yard in-house. The garden is embracing the office, and the office embracing the courtyard greenery. And also we have the exhibition space. Accompanied with the models spreading in the exhibition space, it will be clearly tracing the experimental process, that how we achieve the practice through the making. In sequence, the architecture design office would become a laboratory for design research. And as Bruno Latour proposed in his book, Laboratory Life, the ultimate object of research is to experiment, and through experimentation to establish a kind of credibility. So as analog of the scientific laboratory, the design laboratory would lend a rethinking on the traditional authority of architecture design. In that sense, we as architects, especially in the design process and in our career, would not just have to build our authority, but also we can use the new tools, new machines to help us to set up our authority and the credibility of the office and the architects. And here is the in-house robot yard in my office. The gantry robotics factory was set up in 2015, which spent almost 3 years for us to settle down everything. Follow the dream of the fabrication future, we develop actually the heart of the future robotic factory. Inside a design studio, the range of our work is not just design on paper and making models, but also we test to doing some one-to-one skill mock-up and set up some new fabricated tools to help the industry to update the version of the future fabrication. In this situation, we would create a mutual cultivating relationship between the design, research, and the build practice. And Latour's notion that the scientific result would only have meaning through its position in the network. Then the meaning of design research will only be reviewed through its relationship to the practice networks. In the end, practice becomes the context of design research, and in return, the research would perform as a driving force for the design practice. So on this platform, we invited different architects and professors to collaborate with us. We mix research together. This is a pavilion we just finished 2 months ago. The collaboration is between Archimangus, ICD from University of Stuttgart, and DDRC from CUP, Tongji University. And both of us sent 2 PhD students, candidates, and also some professional researchers. So the team, including 6 to 8 students, spent 1.5 months to research on this pavilion and make it in the lab in Shanghai. So the process actually is based on the simulation first. We designed the certain kind of tools, the sewing machine could be put on the robotic's head, and also we make the form finding process to generate the arch, the self-standing form, and based on the structure performance. And then we make research on the components based, this kind of prototype, how to use the sewing machine to make the whole pavilion in the lab. So through the research process, I think it's kind of prototype, which was invited by the newly open museum in Shenzhen, south of China, and was collected by that museum and put there permanently. So the material is from this kind of plywood. We use 5-axis CNC to milling everything, and it's overlapped as a flat one, and then we're folding them and use the sewing machine to make the joints. So the whole process in the robot yard is around 25 days, but the design process and moving to the on-site work spent totally 1.5 months. Through the process, I think both of the 2 universities set up a new platform, a new network, because we can learn the knowledge from each other, and also we can, working especially for this kind of experimental pavilion, to make a manifesto for the future, which is totally based on this kind of new tools. Another example is in the last several years, we focus on the robotic 3D printing. So this kind of simulation of the nature, bionic nature, and how to sewing by machine. This is a tool head we developed on robotics. The 3D printing always like just counter layer printing, but we try to figure out if it's possible to print in the space. We can position by the tool head and tool paths, and also they can self-support by itself in space, and precisely, very efficiently, to create some new spatial structural form. And the tool head is a key aspect we focus, and which integrate different kind of technology, including the mechanical things, including the electronic control system consists of the operating interface and also the central controller. And after that, it's not just the last one, it's the first tool head. And we make a generation by generation. Actually, right now it's the 5th generation of the tool head. We want to print different materials, and also we test different kind of materials. Right now we use is modified plastic, which is developed by my team. It's a special plastic by different kind of material. And we use them to test in teaching different kind of studios. This is a year, anywhere year 3 students. We try to simulate the chairs and learning from the silk spinning process. And the chair is totally, the form is not just a representation of the chair form, but we try to design the form through the process of the spinning of the silk. So the structure is set up by 5 kinds of density of the material. So the process of the make the new form. So you see this kind of representation is not a model. It's just a kind of diagrams. The diagrams showing the density, the new process, how we design, how we're making things. And then we transform this kind of diagrams to the two paths, different kind of density, 5 different kind of density of the two paths, and make the structure performance of the chairs. And after we print it, something like this, and people can sit on it and have a very good feedback to about it. And also we print different kind of chairs. We don't have time to introduce very detailed things, but there's also similar methodology. So this chair spent only 7 hours. We can print it, customize everything very fast. The design value is most important. And also, after that, we're thinking about not just printing furniture, we want to printing some structure things. So we try to print a wave bridge, which is sitting in the entrance of our university from the ground floor to the basement. We print two chairs, two bridges, actually. One is 4.5 meter span, another is 14 meter span. And so the speciality for this two is not symmetrical and can encounter different kind of situation. And we should make it very efficiently. We just printed everything in 8 days. So the process of the design is based on different kind of simulation. Actually, the choose is not just by the architects. It's Minipati is a structure engineer toolbox building the Rhino. So the architect students, we teach them how to learn in this kind of simulation process to reduce the material and use BESO, which is an algorithm design methodology, to reduce the material and make the minimum pass for printing. And then we optimize the details to evaluate if the details are good. So we change another structure plugin software, the name is Karamba, to test the details, if the details are reasonable. And also we use another software, Abatus, to check, to fix if the details are good enough for the printing process. And after that, we set up on a robotic platform. So the printing process spent totally 320 hours. So we use 3 robotics, printed day and night. So the whole thing spent 7 days to print the 2 bridges. And the students need to, we teach them how to build this because it's cut into different components, totally 8 pieces. We need to think about how to install them in very short time. It should be in 1 day and night. We should finish everything. So this is a process. We record how to put the 8 pieces of the components together. We spent 18 hours to install everything. So early morning, I go to the site. It was finished with no news, just everything compressionally supported in the university. So I was asked to passing through firstly passing through in the early morning. So we record this. So very happy, safely passing through. And after that, after we finish it, a lot of students from the university, because engineering school and the material science school and the computer science school is separate from our school. But we found the students and professors, most of them very interesting, is not a professor from our school, but this kind of crossing discipline. For example, the material engineering school, some professor asking for the material and give us a very good recommendation to update version of the material. So this is the bridges. And in the opening, Patrick Schuma coming, and 2 of us passing through this. And after that, this is the Secretary General of China Architects Society. He asked me how many people is maximum sitting for this bridge. I told him 5. So he's very brave and asking 5 people to standing on it. So it's also very safe. So after that, it's not just a bridge. We want to testing if it could be some pavilion. Could be very close to the buildings. So this is the pavilion we print 4 months later. It's like 3 months ago, last year in Shanghai. So the process spent 4 months, but this time we try to challenge this like a pavilion with a certain kind of span, 11 meters to 11 meters. The height is 6 meters. So the design process record is totally different to the traditional design process. The simulation, optimization, and cross-discipline from architecture to structure engineer, different kind of software built in the process of the design. And we need to carefully evaluate all the details, including the same thinking methodology to the chairs, the density showing the structure, which part is weak, which part should be strong. And through this kind of density, we translate this kind of density to the chupas, to different kind of chupas on the surface of this pavilion. And then translate it to the chupas, you see this, and make decision how we print it. So the total thing was printed in 22 days by 3 robotics. So this is chupas in the grasshopper to simulate the whole process of the design and the making. And we simulate the process pieces by pieces in computer firstly. And then it's automatically 24 hours printed detail by robotics. So after that, it was finished like this. It's semi-transparent in the forest. At night, the lighting up by could be carrying different kind of light, semi-transparent. So this is RCR, the Prize Prize winner in the opening of the art season in Shanghai last year. And Evan Douglas from RPI and Yuan Zhang from MIT coming in the opening. So after that, we were thinking about to not just print one building, but print the village. So this one was selected as the China Pavilion of Venice Biennale this year. So this one will be built at the end of May. So we're printing right now. So it's kind of showing several pavilions put together in the entrance, in the exit of the Venice Biennale. So not just the plastic, we also try to use the traditional material like the bricks, how to translate this kind of weaving process, the grayness to the rotation of the material. So we developed certain kind of tools, the rulers, and teach the workers how to construct the buildings. Without robotics, that was 10 years ago, we designed this building. So the workers, we collaborate with them and build the wall. This very cheap material and low-cost material, but very efficiently we join the diagrams. So diagram showing the new ways of thinking because it can present the process, present the making ways to the workers, how to construct the buildings. This is facade. And after that, we want to try even more complicated. So we developed on-site robotics to construct the bricks. So this is the building located on the riverside of Shanghai. The site was on the waste warehouse. We collected waste bricks, half of them not broken, so we collect them and use robotics to build again. The roughness of the waste material and the preciseness of the location make a very special aspects of the buildings. So similarly, it's not just about the form, it's about the performance of the facade, the displacement, the stress, wind load. We embed them together to make the facade, why the facade looks like that. So the density, the layout of each piece of the brick is based on the performance-based thinking and design process. Interior is exhibition space, it's an art gallery. And this is bricks, and the next material is concrete. So 10 years ago, we built this building. Everything is by hand, but the geometry is set up by the roof surface design. So we teach workers, we use 1 to 2 model, teach them how to build these buildings. And after several years, we built a fab unit space in Shanghai. And this one is even more complicated because the concrete can span, normally it should be less than 10 meters, but the building is 14 meters span. We designed a certain kind of stairs in the middle, and the stairs is a structure, and stairs is, everything is by just one material, just by concrete. So we designed the circulation and find the different kind of height and different connection in the space, and we try to translate the kind of circulation to the structure system. The ways is similar to the plastic printing. We reduce the concrete material by BSO algorithm, structure performance simulation tools. And then this is a traditional analysis structure engineer they're doing. It's very reasonable, but the left one is new thinking methodology. It's kind of a diagrammatic reduce material process to find the form, make the form finding process. So you can find that the plan is not like traditional plan is it looks very thick, but actually it's because it's diagonal. So thickness for the wall is 15 centimeters. So the drawings are different. Traditional drawings, the left one is like the sections but the workers don't know how to construct based on this kind of section. The right one is models. Actually, the building was built by this kind of models. We make 6 different kind of models, from small to the big one, to teach the workers how to location precisely of each geometrical point and surface to build this building. The special for this building is 85% are roof surface, but 15% not roof surface, a double curvature. We use 5-axis CNC to customize the mold in the robotic factory and make on-site concrete support to cast it on-site. The interior space is all one material, but you can see the light, when the light washing the concrete and the light parallel coming into the space, it looks very heavy, but it's a very small space. It's only like 40 meters to 40 meters. So the gravity is made by this kind of new design methodology and the new thinking methodology. So we invited some professional dancers. They make special events in the space, and also some exhibitions in this space. So the next material is timber structure. The left one is in the workshop. The right one is a real project. So we test this kind of, the right one is simulation process. The left one is the real robotic making process. So it's a digital twin, we name it, because simulation is very important to the real fabrication. So we develop the tools, and we teach the industry, the fabricator, how to make the beam, special column for us. So this is a factory. So the material, the ways to laminate wood is tradition, but we teach them how to make the curvature of this kind of structure, and also how to cut it and how to sewing it. This is a tools developed by us. And this is in the workshop, 1 week. We can very fast customize every beam, every column. So 6 students, only several days can finish this installation. And the right one is my real project. We implement this kind of technology to the real project. So this is double curvature surface of the exhibition space in Suzhou, nearby Shanghai. So the specialty for the building is double curvature is all the details. The school should passing through twice the timber structure, once the steel structure. So all diagonal. The human workers, they cannot precisely make it. Only the robotics can make it precisely. So this is the design process, double curvature surface. Totally 365 pieces. And we just simulate 1 pieces of them. It's structure performance-based form, and we pick one of the beam and try to figure out its diagonal passing through the details. So we simulate in the computer, and this is a real process for the milling process. So each detail will spend 40 minutes. So totally we spend 3 months to milling all the details for the building. So only 2 pieces are not right, so because of the tolerance problem. So it's very precisely, very efficiently to make the whole building. And after it's finished, something like this, interior space. The last project, I will very fast make introduction, is in the rural district of Sichuan province. We make this building in 52 days, including the landscape, the buildings, and the interior decoration. Why? Because everything was prefab in the factory. So the similar methodology we developed by robotics. So why the robotics will totally change the industry, because which can precisely customize all the components. And if the fabricator industry change the methodology, they will very efficiently doing a totally different building. So this is a form finding process. It's a geometrical based double curvature surface. And we design all the beams, all the columns, different height, and the joints similar to the last building is all different. So we precisely design all the components and send them to the fabricator, and which can very efficiently and precisely make everything. This is the system of the building, and there's details. So every frame are different because of its double curvature surface. And this is one of them, you can see. So the project is in bamboo. I think it's kind of tradition Chinese culture. It's kind of escaped from the city, and the building was built back to, maybe the back is mountain, and in front of a certain part of the field, a vegetable field, and hidden in the bamboo. And also we designed another entrance space and use bamboo to weave in it. So this is a real thing. So we designed 2 courtyards. One is made by the garden. Another one is a pond. So the material are tradition, this one. The facade is weaving bamboo. The structure is timber structure. And the tiles covered on top of the buildings. But the gesture and the performance of building are very close to the tradition, the surrounding environment. Also, the vegetable field was planted by the villagers. And in the process, we find it's interestingly because all the workers are, this is 65 years old, who is a master handcraftsman weaving the bamboo. And also we find all the workers, 80% are females. Why? Because their husband would like to go to the big city to find a high income job. And their sons, their kids, after they're educated in the university, they would like to find a job in the big city. So it's a big problem in the urbanization process of China. Where is the local industry? If the local industry will find their new opportunity. So after this project, we make a critical suggestion to the local government. This is the whole village, 85 families. The local government invited my teams to renovate the whole village right now. And this project will also go to the Venice Biennale because we're showing the new rethinking and rebuilding for the China village. The ways how we build this village, we set up a very small robotic timber structure factory in the neighborhood and teach the local workers how to use them, and ask the local villagers to build the buildings by themselves. So it's kind of rethinking about the technology and the education. When we develop some new tools, I think the most important is how to make use of them and how to teach the local people to use this kind of new technology. So maybe at the end of this year, we can finish the whole renovation of the village, and especially we design five public buildings of the village, and the others, the families, they can just use the material and develop the facade, everything by the villagers themselves. So it could be a new challenge, a new test of the style, how to renovate the rural district of China. But I'm rethinking on this kind of new technology, education, and the test, if it is possible, to make a totally different future. Okay, thank you.